Well, good morning, everybody. I'm going to talk about integrated water resources management, and I'm going to read because my English. So, water is vital, is necessary, essential for our life. 70% of our planet is water. However, many people don't have access to water in sufficient quality and quantity to their basic needs. But most of this water isn't available to be consumed because 97.5% of this water is salt water. So only 2.5% is fresh water. And of this 2.5% fresh water, only 1.7% of this 2.5% of water is in ice and in glaciers, so we don't have to access to them. 0.7% is in subsoil. So that means that only 0.1% is superficial water, and this is the water that we use to live. That 0.1% of superficial water is more or less 10 millions of cubic kilometers of water, which must supply the world's population. It will mean that we have water supply for 1,000 of years. Why then do we talk about the water crisis? Well, because behind these numbers, there are different realities to consider. For example, in Latin America and the Caribbean, we have the 20% of world's fresh water, but we are less than the 10% of world's population. We are relatively rich in water resources, but we have some difference in size. We have places like North Mexico, like Peru, which are arid places, and places like Chocó, like Amazonas, like Costa Rica, extremely humid, and places where the populations exceeds the capacity of the natural systems to provide water. The same happens in other regions, in other countries, like in Africa, for example, and others. So when we compare these inconsistencies, we realize that in some places exists water scarcity, and that means water crisis. But the problem is not only availability, but also access to water. It's not the same to have water next to you than to have access to it. Access requires infrastructure, requires institutions, regulations, and its set of factors and the harmonic articulation between them that we call the integrated management water resources. Integrated water management resources is defined like a process that promotes the management and coordinate use of water resources, land, and related natural resources in order to maximize social and economic well-being in an equitable manner without compromising the sustainability of vital ecosystems. So, what has to be considered for an integrated management water resource? We have to consider the availability in terms of water supply and quality. That is, how much is the natural offer, but also its quality, because the quality becomes a limitation for its use. We have to consider the infrastructure for water distribution, infrastructure like water treatment plants, like wastewater treatment plants, and also infrastructure such as reservoirs or an hydroelectrical infrastructure. Finally, because there are multiple actors and multiple uses of water, it's necessary to coordinate these actors and these uses, and that is why we talk about the governance. If we talk about integrated water resource management, we have to quantify the water supply. That is the quantity of water to supply all the demands, including the maintenance of ecosystems. Its temporal and spatial variability must be measured, as well as estimate the demand associated with the different uses of water. For that, we have to make meteorological measurements like the precipitation, rainfall, runoff, water source flow, water quality, and other measures like evapotranspiration, infiltrations, and groundwater recharge are necessary to close the water balance and quantify the interactions between surface and ground water. Knowing the hydrological cycle is essential. I'm not going to explain this hydrological cycle, or all of us know, but I just want to highlight that it's not as simple as we think, because surely in almost all cases we obvious the interactions and the interactions in this flux from the groundwater and the superficial water. And also the effects by natural events and by the different human activities that affect flows and the magnitudes of hydrological process. For example, the change in land use is one of the main factors that affect the hydrological cycle and implies a modification of the existing natural cover to change for agricultural, industrial, urban areas. When forest areas are altered, infiltration decrease and the runoff, the infiltration decrease and the runoff increase. You can see in this type of flux with cover and without trees. And the aquifer recharge decrease and the impact on the flow regime in the streams change. In cities, the ground is covered by waterproof materials such as pavement, cement, roofs. Then the infiltration decrease, the runoff increase, and it's evacuated by insufficient urban drainage, causing or inciting influx increases. Nature-based solution, we mentioned in the other with Mike, can be part of the solution of the integrated water resource management, like this, like permeable pavements, retention gardens. Well, the demand refers to the water that is needed for all the uses we give to water, for domestic uses, industrial uses, mining, hydroelectrical generation, aquaculture, navigation, and also for recreation uses. What we need to know about the demand, about the water consumption, is that it's necessary to do it in terms of quantity and quality. Because we have a growing population that demands greater water consumption for their daily activities. We have a growing urbanization that demands more and more water for its industrial, commercial, and energy activities, and that demands a greater food production. In relation to water quality, this limits the use of water. If we contaminate the water, it will not be able to different uses. And water crises are generated when this demand exceeds the water availability in quantity and quality, and many times the solution has to be route to reduce those consumption and measures of like a program of efficient water use. Another aspect that we have to take in account when we talk about integrate water resource management is the effect of climate change. And around this topic, there are some risks. One of them is the affectation to water sources. Our aquifers, our rivers, all the sources that we use by all the activities and the water sector, the energy, the agricultural sector will be affected by climate change. They will be diminished, and therefore the availability of general water decrease. Another risk is the extreme natural phenomena. Climate model projects indicates that the drier areas will be more arid, and the the humid areas will receive more water. So we are talking about the presence of extreme events and the increase in their intensity. That means more pronounced droughts and floods. And the other risk is about rising sea levels. Latin America and the Caribbean, for example, is a region where 3/4 of its population lives near to the coastal area. With a rise in the sea, we will have more and more flooding at the coastal livings. So think if that city near to the coast is a city with an increase in rainfall. What can be happen is that the urban drainage, it will be insufficient to prevent flooding, which is one of the biggest effects in the Latin American and the Caribbean. So you also have to consider disaster risk management, which is usually forgotten and only appears when a disaster occurs. What we need is a more preventive approach. Okay, the increase of the population, of the economic activities, and therefore of the consumption generate conflicts and competition by the access of the water. Solve these conflicts implies individual and collective actions, decisions to achieve equitable, efficient, and environmental sustainable management. So when we talk about governance, we are talking about the way we govern each other, how we govern the water resource to have an efficient and fair distribution of water for all. Imagine a watershed. This is a watershed. Imagine that in the upper part is a spring, the born of this river, that provides water for the people, for all the people in this watershed. As we go down of the watershed, we find different uses. We find cities, we find industries, farmers, which depends on what happened in the upper part. Imagine what happened if in this part a farmer put a big crop with a long consumption of water. What happened with the consumption of the other persons that lives down to this person? And what would happen if, for example, this farmer cut the forest, so decrease the infiltration, and maybe you have a disaster. In this case, for example, live up to the watershed is an advantage. Now imagine that we have other farmer, an ecologic farmer, for example, that live also in the spring of other river in this watershed, and he wants to plant tree. So he invests some resources to protect the spring, and some months later increase the flow river. But he has no more money to continue planting trees. Do you think that the users down to the watersheds give him economic support? And do you think if these users can be changed his decision if she knows the importance of what he ecologist farmer does? So what happened in the upper part of watershed affects all of those who are in the down in two dimensions: the provision of water and its distribution. That means to provide water and good quality of water, and to distribute water of all uses in an equality manner. So this is what we call the vertical problem of water governance. So water governance is a concept still under construction, but it's clear that when we talk about water governance, always we talk about that governance involves actors, the users of the water, but also other actors like universities, like governance, like enterprises, like NGOs. Governance involves actions and decisions that affect the provision of water and its quality. Involves also instruments and institutions, rules, norms, agreements to coordinate these uses of water. We can talk about sanctions, we can talk about protection mechanisms, we can talk about incentive programs, cleaner production programs, for example. In my opinion, this is the principal element of integrated water resource management, because the technology is there. Sometimes you know the needs and you know what solution do you have to implement. But sometimes these are not done for a lack of political will, for egos, or for lack of information. And it happens too that there are resources, but many initiatives doing the same thing. So initiatives with poor resources and limit scope. Other times it's lack of information or information of lack of knowledge of the dynamic of environmental systems. And that's why we say that the water governance is a problem of collective action, because we have to coordinate. Now we are going to present three examples of projects that in relation to this integrated water resource management. Two of them are projects that I coordinated a month ago, and the others are a project that we are doing in this moment, and is like a zone of one of the projects that I'm going to tell you. One of them is the Integrated Water Resource Management Plan for El Retiro. El Retiro is a medium-sized municipality, 4 minutes for Medellin, our capital, our city where we live. And in this region that is being highly urbanized. The objective of this plan, of this project, was to formulate an integral water resource plan. We made a diagnosis of water supply, of water demand, of water quality. We identified the conflicts of water use, and also we identify ecosystem services. Then we do a prospective phase in which we build we build 4 scenarios. First, the trend scenario, and then 4 futures scenarios. And with the diagnosis and these scenarios, we construct a possible scenario that give us the line, the route to formulate the plan. This is the route of the prospective process. And finally, we formulate the plan with programs and projects like risk plan management, water monitoring network, basic sanitation, good productive practices for economic activities, efficient water management, ecosystem protections, and environmental education and capabilities. We have the participation in all the process in the beginning, in something that we call participatory planning. The other project is called Plan Quebradas. Plan Quebradas means like a little river stream. So Plan Quebradas, it was a program that we managed in agreement with the environmental authority in a metropolitan area called Área Metropolitana del Valle de Aburrá. There is a long river, Aburrá River, and the streams, there's tributaries of this river. Its objective was to formulate and to implement water governance models to involve different stakeholders to implement environmental action in 19 micro water sheds of the Aburrá River. We began to take approach with the municipalities, identifying stakeholders, and then we make like a characterization. We identify critical points, wastewater, with water's critical points, loss of plants cover, solid waste, etc., and formulate projects in sanitations, in management risk, in conservation and ecology connectivity, and other projects in education and environmental education, We did through, okay, and then we start something that we call synergistic movement that consistent in articulation with the different actors that are part of the same territory in an exercise of co-responsibility, joining efforts to implement this proposed project. We did that with different strategies, breakfast with enterprises, interinstitutional committees with the communities, with the governments, with the enterprises. We achieved agreement with the actors and some enterprises. We did actions like cleaning rivers, activities with the community on the Environmental Day, and we involve the pork sector in Colombia and to formulate projects in best practices for these sectors. And we made this type of water governance model for this program. And the best results of these Plan Quebradas is the association with EPM, is the public service enterprise to implement a beautiful project called Forest Ranger Delimitation and Enrichment of La Quintero Reserve. La Quintero Reserve is an area in the upper part of one of the micro watershed of Plan Quebradas that supplies the aqueduct of a municipality called Barbosa, and that's the importance. That's why we want to do this project. The project has different work packages. One of them is the forest enrichment, in which we have planted 17,000 native trees, some of them in the reserve and others in others properties near to the reserve, and others with the community in an activity that we call forestry, community forestry. We also did a legal analysis of this reserve in order to make a formal declaration as a protected area. And the most beautiful thing about these projects is that we do that with this group of forest rangers, residents of the municipality, and who were trained in different topics, in territory reading, first aid, ecosystem service, bird watching, fire management, risk situation, narrative and communication, environmental educations, and more teams. The reserve wasn't known by the inhabitants of the Barbosa, but thanks to the work of these persons, all of the people knows now the reserve. So we are working in the appropriation of that. We are currently doing the identification of plant species in the reserves. We set up a forest monitoring plot, and it seems like we have a new species in the reserve for the science. Okay, this is 3 cases that I think are in relation with integrated water resource management from different approach. Thank you.
Okay, thank you.